Welcome to our session today. My name is Gilbert, and I'm a partner architect at DataStax. And my team focuses on developing and managing cloud partnerships. And Pivotal, of course, is one of our key partners in our ecosystem. And today with me is Wayne Lund. He's an SME for the Spring Cloud Dataflow. And today we're going to talk about how to unleash the power of data using two key technologies, Spring Cloud Dataflow and also DataStax Enterprise. So let me get started with introducing who we are as DataStax as a company and what we do. Then Wayne will talk about the Spring Cloud Dataflow. And through a live demonstration on Spring Cloud Dataflow. So DataStax is a 500 employee company, and we have over 500 customers in 50 countries. Our main product is DataStax Enterprise. At its core, we provide the best distribution of Apache Cassandra. On top of that, we also have other advanced features such as search, analytics, and also a graph database. And we provide a multi-model database system, means if customer want to store a simple data model, it means you can create a key value pairs, or you can actually create tabular SQL table formats. And if you as complex as having a highly connected data, you can also use a graph database. And we also provide a very user-friendly, intuitive IDE. We call it DataStax Studio. It's a notebook-style, browser-based IDE, allow developer to create SQL statements and also create Gremlin query when you are doing graph. And finally, we also provide a visual management tool called DataStax Enterprise Ops Center. Ops Center provides you with a dashboard so you can actually monitor your DSE cluster health. And also we give you some best practices, services, and also backup services. Mean you can actually use a GUI-driven dashboard to create your data backup onto S3 or other NFS server. So the key three elements I want to highlight today is sitting on top of our Cassandra database. The first one is DSE Search. It's through the Solr integration. And today, DSE running at version 5.1, and part of our stack, we are using the Solr version 6.0. And these provide a full text search capability, faceting, and also aggregations, giving the user the ability to search on a large data set sitting on Cassandra database. And analytics is through our Apache Spark integration, meaning you can run Spark jobs, and you can run streaming analytics on top of our clusters. It's a single unified platform, means you do not have to install this separately. It's a single installation. And through our acquisition of Aurelius about 2 years ago, we got this graph database. And the whole team, when they came on board, we rewrote the entire Titan graph database so that we can leverage our search capability and also the Spark capability, meaning you can get a more optimized graph experience. So this is a typical customer scenario. Today customer may have a dozen, couple dozen, or maybe 50, 100 applications. Right? Each application has its own data requirements. Right? Some application may need to have a simple key value store, and some application may benefit to use a graph database. Right? We give them choice. Then again, it's a single product installation. They just basically have to turn on certain features. I want to turn on graph. I want to turn on, then they can have a graph database. Since the data being stored on our database, and customer want to do more with the data. They want to find insights from the data, right? So meaning they will probably enable search, meaning they have a Solr BA enable, meaning they can create index, right, on the table. As new data comes in, we have the live indexing capability, means that once the data comes in, we index the data. Or when the data get updated, we index the data automatically. So customers do nothing. For the batch analytic, it's coming from, again, the Spark integration. Actually, we can run daily rollup, days end jobs, right, with on top of the cluster, running a large, on a large data set. And streaming analytics, you can actually running, Spark streaming, right, running those jobs on top of the Cassandra, our cluster. And the good thing about a cluster is, since we integrate, means we will elect one of the node become, the Spark master. It's all automatic. As a user, you have to do nothing. And finally, customer, if they have highly connected data requirements, right? They need to have a graph database, and very often that they build things like recommendation or customer 360, right, application. They may make use of a graph database. So let's go deeper on the DSE search. So in this particular setup I set up a DataStax cluster, and I enable search. That means the Lund indexing server will be installed on each of the node there, right? So it means as data comes in, we do live indexing, and we also be able to distribute the Solr query on all the nodes, and then they will come back and consolidate the results. It's a distributed query optimization that we put in. So if you do not have a DataStax cluster with search enabled, then you may have to have a separate Cassandra cluster and a separate Solr cluster, right? Then you have two clusters to manage, right? That we have high maintenance costs, and also you got split link problems. And for the data being stored on Cassandra, you have to do the ETL yourself, right? You have to replicate the data or move the data, right, to the Solr cluster in order to do search. And in this, another setup is, this is actually a single cluster. We divide it into two data centers, right? The top one is the Cassandra NoSQL database, storing the operational data. And you have an application in blue, which actually providing maybe some customer application, right? External facing to the customers. And it will actually be using by the customers. And the bottom one is the analytics, which is the Spark cluster, you may call it, which inside the same DSE cluster. And so basically, all the the Spark jobs, right, will be only running on that data center, meaning it will not be affect, right, the performance, will not affect the latency on the operational Cassandra data center. And again, right, in this technology, we have the replication. Data replication technology means as data comes in, right, update or new data comes in, we will silently replicate onto the analytic data center. And also, we use the underlying Cassandra technology to provide a distributed system environment. Means you do not, our Spark cluster doesn't need a zookeeper. And DSE Graph, again, I said, is through an acquisition, right, of Aurelius. And basically, customers use it for majorly 3 use cases. For customer 360 means customer want to understand their customer in a 360 perspective, right? Through all these connected data information like vertices and edge, then we can find out, how close are these people between these people, and how we can actually provide, customer provide a recommendation, right, to their customers. And also, it's a great platform to detect fraud, meaning you can find any, embedded, or fake transactions. A lot of our customers putting DataStax already in production. Without enterprise-grade security, they won't do it. Out of the box, we have LDAP and Active Directory integration, and also you can use Kerberos to authenticate. And it's a great way to provide single sign-on to all your different data domains. And we not only encrypt data at rest, we also encrypt data in motion. We have client-to-node and node-to-node, the security. And we also provide a configurable audit trail, meaning we have out-of-the-box support Log4j, so that you can actually audit all the activities being added on to your database. So you can see a lot of big names here. So over the 7 years, we accumulated a lot of big customers, and you can see this customer has been using many different kind of database, right? Some have been in the industry for 10 years, some 50 years, and the database to them is a normal thing. They need the database for the existing application. They come to us for the new type of application, for cloud application and for microservices, the implementation. They need a new kind of database to solve, the new problems. That's why I can see all these, company like Safeway, Macy, and UBS, and these company coming to us for a new database requirements. And we have a handful of customer running DataStax cluster over 4 years at 100% uptime. So let me pass to Wayne to talk about the Spring Cloud Dataflow.
So I wanted to give you kind of a peek preview of the private beta we have out on Spring Cloud Dataflow Tile. So I'm kind of curious, how many of you have been through the journey of Dataflow and actually used Spring XD? Are there any Spring XD users out there? And then Spring Cloud Dataflow? Are there any Spring Cloud Dataflow users? Okay, so it is kind of a new group. And the difference here, you'll see from this picture that Spring Cloud Dataflow runs, like PCF does, on many platforms through this concept of deployers. So you can run Spring Cloud Dataflow on Cloud Foundry, on the PC Dev environment, which is your cloud in a box, Yarn, Mesos, and Kubernetes. Today I'm just going to focus on the fact that we now can deploy it as a tile, similar to what we've been doing with services like Rabbit, MySQL, Spring Cloud Services, etc. So let me increase the size of this a little bit. What I have here is a developer environment. I'm not going to show the DevOps because we don't have time. So what I'm showing here is from an application developer from the App Console. And a DevOps team has already come in and deployed the Spring Cloud Dataflow tile. So when we start in the marketplace, you'll see that there's already a Dataflow server tile available. When I select that out of the marketplace and pick the plan, and I've already done that in this case, it will automatically deploy the services that Dataflow server needs to be able to run the Dataflow server. If you've been used to using Spring Cloud Dataflow in the PCF environment, because it's a Spring Boot app, you can simply push the app out there, and then you're responsible for making sure that there's a Redis server available if you're using Redis for the real-time analytics, or a MySQL database service for something to store the metadata that Dataflow server stores, or a Rabbit, or a bus. Whereas with this, if I go back to the demo space, and for those of you that might not be familiar with the way this is set up, we set up an organization for DataStax and just created a demo environment, and I have used the Spring Cloud Dataflow already to deploy a stream. And I'll show you that stream in just a minute. And you'll notice there's a list of 7 services that we've created that we're using, and one of those happens to be the Dataflow server. The Dataflow server, when I said create service, created these services that kind of had the GUID-generated names on them that it was dependent on. So you'll see there's an analytics, which is Redis, there's a data store, which is MySQL, and there's messaging, which is Rabbit. You're not required to use those, but out of the box, if you use the default installation, Spring Cloud Dataflow tile will leverage services that it creates and binds to. So all the apps that are deployed by the Spring Cloud Dataflow shell or the UI will take advantage of those services that are there. So we have deployed this, and typical to the data services, when you go to the server, you can click on the Manage tab, and that will take me out. And I already have one up and running, so I won't go through the login process. Whoops. It go? I'm sorry, I think I'm on the wrong tab. I apologize. I lost the tab that I was going to run, so let me do it this way. Go back to the path into it. We're using Okta for our login for this environment. And this is the dashboard here that was brought up when I selected the Manage tab. So what you see here, and I'll enlarge that so you can see this, is that you have the option of pulling in out-of-the-box components that you can use in your Dataflow orchestration. So we have sources and processors and sinks, and there's also tasks. In this demo that we're using today, it's almost easier to see this from the command line. If I show you that I have, see that okay from there? This lists them in columnar style, the various out-of-the-box sources, processors, and sinks, and I don't have any tasks that I've imported. We created a custom tab called Meetup RSVP. Anybody gone to a meetup? Did you realize they have an API for Meetup? And we're using the API, and we simply cloned the Twitter stream sample that you can get the source code from and changed just a couple of things to make it appropriate for the Meetup RSVP API. So that became our source of data. Now, the problem we had when we were using the Meetup RSVP was that the data that came in a lot of it didn't have the data we wanted to insert into Cassandra. So the first thing we did was create a Groovy filter that threw out the data that didn't have the fields that we were going to use in our analytics processing in Cassandra. And then from there, we used a Groovy transform to simply flatten that data so that we could use it for the insert statements. And then we inserted it into the sink, which is Cassandra. And the other thing that we took advantage of was that Spring Cloud Dataflow has this idea of taps, so that as the data is flowing into your sink, you can show some real-time analytics on the data as it's streaming through your system. So we can show that system here. We're going to be doing this again. I'm looking for my PES environment. Okay, I'm doing it again. There we go. So when we come back to the tab, there we go. No, that's not the right one. We could take a look at the streams and how they're defined. So you notice that we have the same things that I showed that we used out of the box of components. And we can look at the details of our stream orchestration by clicking on the details, and that shows us what the flow looks like. So in this case, you see that we have the Meetup RSVP that was our custom source, our two processors, and our sink, which is Cassandra. And then we have the taps that we put onto that. And so that's something that's allowed by the UI admin. You can also go to the Create Stream process, just as you've done with Dataflow for quite a while now, and I could pull them out from here. Because I used the registration process, it's actually in my palette, the custom source that I created, and then I also have the processors that were out of the box that I can drag onto the canvas, and then we also have Cassandra. And as I drag these components onto the palette, you'll see that it creates these components in the editor. And so we can connect those up, and the DSL starts to form in the top. And every time you see the bar here, that is a symbol that it's the payload from one processor, sink, or source is being transferred via your message bus, whether that's Rabbit or Kafka, onto the stream. And so this also allows me to do things like put the parameters in here if there are parameters that you can pass into the data flow. And so this is all available, and you can see that you can get these definitions for the entire stream or simply for the taps that you put in this case. And finally on this, that we have some ability to get real-time analytics. I've created some field value counters and also an aggregate counter. So I can also create another one. In this case, the meetup has a field called cities, and in that cities we can collect via the field value counter with this bubble chart which cities have the most meetups in it. In addition, I can create another one, and you can see that I can select the other field value counter, which is the venues, and also we'll pick the other chart that's available, which is a pie chart, and enlarge that. And you can see that the pie chart is also available. So that's what we could get real time. And the final result of that is that the data gets filtered, transformed, flattened out, and inserted into Cassandra, where you can now use the DataStax Studio to operate on that data. So I'll turn it back over to Gilbert.
Sure, thanks. Can I switch the laptop?
Yep, okay.
So Wayne have talked about, let me make sure you can see my larger. So Wayne have talked about how to configure and how to create a data flow on the Spring Cloud data flow, right? What we have to do on the DataStax side to enable this demo is we have to create a table, right, on a database so that he can sync the meetup data onto our database. So first thing you have to do is I use the DataStax Studio, right? Then I'd connect to my DataStax cluster. Then next thing I have to do is to create key space, right? I need to create a key space for my tables. And this IDE allows me to easily do that because it provides autocomplete and also error correction. So meaning if I have either typos or syntax issue, and DataStax will prompt me and let me know in the studio. So next, I need to create tables, right? Then we need to create tables so that we can store the data. And one thing I want to highlight is this field. It's a new field. This field doesn't come from the stream. It's actually our geospatial search. We'll be work on the geospatial search, this field. And in order to create this field, we leverage the Groovy transform. So he factored all the data, and also he actually concatenate the longitude and latitude into a common separated field in a single field here called geos. Then next thing, we need to create Solr core. In order to create Solr core, we need a couple things. Right? We need to have a Solr config.xml. Then we need to, secondly, we need to create another schema files called meetup. We know these are the field we're going to index on, right? And you can see we create a new field called geo here. And the type is, lat long type, which we can actually apply the geospatial search on index on it. Then we need to run a couple of commands. I can use a curl call, or you can use our DSE tools. Then you can create your Solr core. Once this is all done, and we're all set up, and Wayne can actually start, right, the Spring data flow, right, to start receiving data from the stream. So let me demonstrate a couple of CQL with Solr extensions. Since DataStax integrate with Solr, means if you create a CQL statement, we could understand this extension called Solr_query. And then you can specify the index field. For this query, I use the index on state, mean I want to search on all the open event we received in the state of Florida. And this second query is a geospatial search, means I want to restrict into state of California, and then I create a rectangle shape so that I'll be able to find all the events inside that geo area. And there's several things we can do, right? In the geospatial search, you can do a point index, or you can use different shape like circle or maybe we call bounding box. Bounding box basically is a square to actually, the minimum square to encapsulate that circle. You have to define the length of the diameter in kilometer. And this is notebook style, and meaning it's very easy to use in runtime, meaning once the data get in and into the database, then actually even some marketing professional can use this studio, right, to create some simple query, and they can actually find some insight from the underlying data. To summarize, what is for DataStax for Pivotal Cloud Foundry? So we are always providing a fully integrated capability on Pivotal Cloud Foundry. And we always want to be an always-on data platform of choice when people need to build microservices on Cloud Foundry. And we want to be the leading, and we are actually the leading distributed database on Pivotal Cloud Foundry. Maybe for your next project, right, you can actually try using DataStax cluster for your database need. Just to also summarize what we have built for demo for this event is, let me walk you through quickly. First of all, I need to use DataStax Studio, right, to set up the key space. I create the tables, and I create a Solr core on that meetup table. Then we actually create the Spring Cloud Dataflow logic, right, to do the ingestion of data from a meetup open event streaming data. And going through, also we set up the underlying RabbitMQ as the message bus for this whole environment to set up our streaming data pipeline. So meaning we continue getting new data and store on database. And once data stored on the database, automatically indexed. The second part of our demo is we create a Spring Boot application, which also use Pivotal DataStax build a Pivotal tile, which allow you to create a service instance. That service instance will give you a service credential so that the Spring Boot apps can use recap services and connect to the backend DataStax cluster. And the use case of DataStax Studio in this picture is imagine there's a marketing professional so that he or she can actually run some Solr query based on her requirement to find out what are the events happening in certain area. The key takeaways from a session is you could use Spring Cloud Dataflow to define and orchestrate the data flowing into source and process, analyze, and flow data downstream for downstream processes. In our case, we use DataStax cluster. And DataStax Enterprise will serve as an always-on data platform to store your real-time data, and will be able to use search, DSE Search, to generate meaningful insights. And finally, DataStax Service Broker tile we built on Cloud Foundry, and you can use to easily bind your Spring Boot application to our database in the cloud. So next step, what we want you to do is to share our demos with your colleagues. And here is the URL to our GitHub repo. So we put all the asset we built for the demo on this GitHub repo. So please go ahead and go home and back to the office and try to recreate the same environment.
Any questions?
Any questions?
It looks like not. Thank you for coming.
Thank you.